morning, everyone. Hope this is better.
Yeah, okay. No, it's okay, fine.
Okay. So I can just start the presentation. Okay.
Yeah, okay. We can see your screen.
Okay. Uh,
Yeah, Praveen. Dr. Praveen, can you
thank you.
start your presentation?
Okay. Thank you. Thank you very much for everyone for this opportunity to present my research uh, in human machine teaming in a broader area. Today's presentation is the human factors in AI, creating collaborative agents that complement human capabilities. So, in the today's day and age, we are moving towards more a collaborative AI than towards a completely replacing human actions or human beings. So our goal right now, our goal and our directive at our company is designing AI systems where they can be better teammates with human beings, where they can assist human beings in completing the various tasks, industry, in academia, effectively. So, if we remember previous uh, Watson, for example, in the Watson era, IBM Watson, at the time, the goal mostly is like, for example, in the early days of AI, the goal is to beat a like a chess player, a human chess player. So slowly, AI is got trained in that, and they got and they started beating human players. And then the next step came into picture where a team of human and AI started performing better than the AI and the human individually. So this where the concept of teaming up with the AI came into picture. So the evolution is basically trying to like to figure out what is the best way to integrate one and more human beings with one and more intelligent systems. AI, so, to create a team that effectively completes critical tasks day in and day out, not just mundane tasks like generating not just large language models that we generally have right now, effectively working to solve many tasks that industries. Um, so this shift of directive generally came in many ways. So, for example, the previous research from the Air Force Research Laboratories and some of work Dr. Peter did previously in collaborative AI. So, these all led to the development of a new field of human machine teaming. Also, this created government directive in USA, providing an importance to the human machine, giving an importance to the human machine teaming. So our company's directive started from that point onwards to figure out what are the human factors we need to consider when we are developing a new AI, how to build a team. Through team building exercises, we figured out we need to like figure out methods to build teams. So we started working on the best frameworks to develop the AI. So, what are the various factors to consider? All the research started from that point onwards. So in this, there are very broad definitions for to define human machine teaming. The simplest definition is one human or more, one intelligent system or more cooperating to complete tasks is broadly defined as human machine teaming. That's the simplest definition. We came up with a more complex definition, which is published, trying to emphasize what are the various components we can consider in developing a HMT, human machine teams. And it's kind challenges in human machine teams is well, how to develop a interdependency in AI. So what kind of actions can lead to what kind of results, what how the human expectation of what can be the AI's response in any given scenario. That's how the best team works. Is if you know your teammates expected action, you can be always guessing. As long as you are 99% sure, like your teammate is going to perform XYZ tasks, for example, then you know that they are going to it's going to be a reliable teammate. And how to interact? Humans can interact very easily. The world is developed around human interaction. So we have to have a system that can interact with AI as much as simple as we are interacting with humans. So an intuitive interface, what kind of components we can consider to design this interface, how a trust is and reliability is built between the human and machine teams. So these are all the various challenges we are trying to figure out in building an AI that becomes a best collaborative teammate in industries and academic applications or medical applications. Um, so in this exploration, what we came up with is a metric table. So we did studied almost like 250 studies of published work, patented work, or a demonstrated work showing what are the metrics, various components that people measure, how to measure them, and some of them are subjective, some of them are objective. So we came up with a color coding metric system that we can use to measure each team member in a human machine team. So you want to measure how human is performing, what kind of aspects you want to monitor in designing a human machine team. And at the same time, you want to design an AI that can work around human, that can identify the difficulties, the challenges of human, and try to replace, try to adjust to those challenges At the same time, we need to train humans to work with AI systems as a team. Mm. And what kind of metrics to correlate to what kind of affective measurements. So we came up with a bunch of metrics here. So we need to figure out what these metrics can we can measure and how reliable these measurements are in designing the AI systems. We did a couple of human studies in 4, 5 scenarios. Try to figure out if we take EEG measurements of humans, how much we can relate that stress, and then how we can transform that stress metric to design like an intelligent system that says, okay, if you are increasing the stress of your teammate, then the result of your team performance is going to go down. These kind of metrics, correlated metrics, we worked out. This is the ongoing research. We did a couple of studies and developed a few AI-based models based on our metrics. But I think it's it's a repeating work we do day in and day out, trying to improve the system every day. So, in overall, like from 100 metrics, almost, we quite narrow down the what are the important metrics that we need to focus to improve the designs, both human machine team design, AI designs. So those metrics in humans, we able to understand that each teammate, how adaptable they are to a new system. So yeah, that's where the human machine, like a team building exercises come into picture. How much team building exercises they will be needing, how much they will rely on intelligent systems. So will they trust a robot or an intelligent system? How effective their trust is? Will they trust the results of it? Will they trust to it performs a task or not? So subconsciously, consciously, at what level they will settle down with this team member to perform, how they can better utilize the tools. For example, nowadays, almost like 1,500 companies use various levels of large language models in their day-to-day operation to improve their workers' efficiency, their engineers' efficiency. They use Microsoft cobots to code collaboratively. At the same time, they use data researchers, they use Perplexity to do the fact checking research sometimes to avoid the trying to do always be careful on the avoid the hallucinations of large language models. So there are a couple of drawbacks and but the quite rapid state of improvement, how fast the LLM models are changing. That's how the human adaptability changes. If they are able to adjust the fast-paced changes, then their productivity starts increasing in their operations, day-to-day work. At the same time, in the AI model, if you have an expensive intelligent system that you design to work with your teammates and they are unable to use it effectively, then that's not an effective teammate. So if it stays idle, produces a lot of errors, unable to understand why you interact with them. So these are all place a key difficulties when designing AIs. So we've jotted down those metrics. What are the best ways to figure out these operations are, and then using these metrics, we started developing AI system to do human studies. So in these human studies, for example, we did a couple of case studies on training the healthcare workers in various levels because these in health care industry, that's one of the industries that need regular training. They have a specific defined protocols to follow. So this is one of the easiest fields we can like test a collaborative system where they can use an assistance. If they can use an assistance, in which steps they can use an assistance. Is it in training they can use an assistant to train them better? Or is it we can use an assistance in treatments to follow the checklist to make sure they follow each and every protocol, that they don't miss anything, they record every results. So at the end, to how many lives we can save or improve, how much workload we can reduce on the caregivers. That's an end goal there. So we came up with a specific architecture for this intelligent assistant and then a team member. So the better interaction we observe is through natural language processing. There are different interacting methods. We know already existed, like we can interact through touch, screen, gestures. But when we are performing tasks like as a life-saving task, you want your hands always free. So the best way to interact with the caregivers, nurses, or healthcare providers, emergency or in training also, is through natural language processing. So if your NLP is good, then your entire HMT improve interaction radically changes, how better they can interact, how quick they can form a team, all those things. For example, if the number of times you do a command, the number of times it understands it has to be the error has to be 100:1 for a team to form an AI to become a collaborative. So, for example, in the early days of Alexa, like Amazon's natural language processing, we tested all the NLPs available with our architecture. So we tested Google Assistant, we tested Amazon Alexa. So in the early days, like when we are doing this test in 2013, 2015, we observed it's like it's becoming very difficult task just to interact. So the team formation is becoming very difficult at the stage. But when the natural language process are improving, the lag time is reducing. All those things led to successful team formations that we observed in our test recently. More in 2022 or 2023 experiments. So this 8 years of NLP development led to this formations. Before that, it's quite not possible. So we came up with some generalized architectures people can use and put them out, like what kind of interface they can use based on what is the application of it. For example, a coders don't need a visual interface. So if you are interacting with a coder, building a software model, building a store or a storefront or something like that, you want them to effectively understand your code or what you want to do and then do the perform task completely. So you don't, they may not be interested to interact with NLPs to just write a code. So it's very lengthy command. You just give the command code, understand the code you want, and generate the code you want. So LLMs can play a critical role in that compared to NLPs. So these kind of changes in interface, we understood that these changes form a quite important and critical role in building an HMD. Each change logarithmically has quite different team formation is possible. So in the early days to current interfaces we have available in Think, nowadays we are able to see successful team formations with intelligence systems. So because of these interface changes, interface plays a key role in forming a team. So that's where most of the metrics we developed came into picture is first interface, then reliability comes into the picture. How much you will rely on the information you provide. If the system hallucination is too much, you don't rely on that system too many times. So the next target will become the trust. The first target will be our target will be interface. Then we want to work on the building the trust between the team members. With these two aspects, we are confident that our teams, our capital company is capable to build human nation teams. Quite elaborately changes. So in many experiments, we use a scoring method, something like this. This is also a published work. So in this kind of method, we see how many errors we are recording in completing a task. We define the errors. We define the steps to be performed in order, like it's a controlled experiment to see if they are able to in a controlled environment at this stage. So we'll see how many errors the system is making, how many errors the human is making. Based on that, we will be able to come up with a score on a scale of 1 to 10. Then the score we convert them into a team formation score. Is that did you reliably make a teammate, or how much trust you have with them, with that HMT intelligent assistant that you are working, or a teammate that you are working. Then you then you see, did you form the HMT with that, human machine team with that, or you just trying to like hallucination that you formed a tree, or you are trying to see, because if you think that you formed a team but you didn't actually form a team, then the system ideal metric going to increase, means the system going to stay idle most of the time, where the human don't trust rely on the system. So it's like we are taking the subscription of a chat GPT or other service, but we never use them because we never trust it. So we are trying to avoid that scenario as much as possible when we develop intelligent systems to various industries, our clients, so that they can use those metrics. So these are some of the test results that we observed. So how effectively is they are able to form teams in various train and test scenarios in controlled environments with a controlled group. So even though the participants are selected randomly with various background knowledges that to interact with intelligent systems, we observe that more and more they have difficulty with the interface or trust. They have difficulty in forming the team. The more the interface becoming and more evolved over the time. We saw that the teaming experience improved, and they started reliably interacting with their intelligent assistants more and more. There are privacy concerns, the data you want to share with your intelligence system, how confident they will like you are with that system, will it be safe with it, how much you want to share with it, all these factors at the end will come into picture. So as long, so it's like you are sharing your SSN with your loan officer. At the same time, you don't want to like the system to leak any information, even between the team members. Sometimes you don't want to reveal the information with other team members because that will break your trust with the machine, which is part of the team. So so that kind of boundary it has to play. Well, those are the rules we need to figure out how to encode them into the system uh, right now. So these are all the challenges we are facing to address in the future. Um, so if you have any questions on our work at our company, KI, I'm very happy to answer. But our focus right now, as you can see, is not just build an AI that works better. We can use the AI that built and try to make it a better teammate to solve your problems or solve your automation problems. So that's the end of my talk. If you have any questions, I'm happy to answer.